Action.
All right, hi guys, we're gonna do number 5. Number 5, all we have is a rectangular piece of cardboard, and we wanna make a box out of it. But instead of like folding or not knowing how we're gonna fold it, the instructions say, I want to cut out congruent squares out of the corners and fold it into a box. What dimension will maximize the volume? All right, so if I cut out perfectly congruent squares out of the corners, probably the easiest thing to do is to make that the variable.
Yeah.
I don't know, did I say that before? I don't know.
I feel like that's right.
Okay. So if you were to cut these out, you would actually fashion yourself a box that looked something like this. Okay, and I want to find out how big this volume could be. And some people say, oh, I could like cut them way out here and make like a really tall rectangular prism, which is fine. I just don't know if that's going to have more volume than something like really wide, right? Really wide and thin. If we could think about all the different ways, it's like we want tall and skinny, wide and thin, or somewhere in the middle. Maybe even a cube. I don't know. We'll find out. We'll find out. All right. So here's the question: we got to figure out if this x gets cut out. These will actually be x's. That's like the height of the box. All right. So you talk to me now. How do I figure out how much if this whole thing is 8? How much is just this part?
8 minus 2x.
Yeah, good. Let's just take away the 2 x's, and that's 8 minus 2x. And this guy here?
3 minus 2x.
3 minus 2x, because the whole thing was 3. All right, good. And actually, this is going to kind of solve itself now, because now I just need to find the volume of the box. So what's the volume of a rectangular prism?
Length times width times height. Wait.
Length times width times height, yeah, or area of the base times the height, whatever it is you want to think about. So my volume is length times width times height. Just for ease of writing and doing, I'm just going to put the height in the front. Oh, okay. All right, what could x be? What could x be?
0.
It could be 0. Like, right? Probably not going to be 0, right? Because it's like, look, there's the box. But there's no volume, right?
Yeah.
Could be 0. I don't think it should be.
No.
But what? Oh, we have a clear domain here. Look at this.
4.
4. Now, if x is 4, this side goes away. But if x is 4, isn't this side already like -5?
Yeah.
So let's go to this side.
1.5.
So it seems that it's got to be somewhere between 0 and 1.5, or else I don't even have an existing rectangular prism.
Oh, that's where
Close parentheses, or open parentheses on the right, gives Mr. Right. Because it can't be exactly 1.5, because that'd be a dimension of 0.
That's okay.
That's true.
Oh, then I couldn't even make.
Then you couldn't have volume.
Yeah,
So
because
can't
it'd be
close
3
it.
minus.
Wouldn't it just be like?
We have to put
The
open
space-time
brackets.
continuum would be
Or
pretty peeved about that.
I think it could be. It could be 1.5.
No, that's why it has to.
No, because
Then that-
3 minus 1.5 is 0, so that would mean that it wouldn't even be a box.
Because
I would just cut it. No, but I would cut it right
Answers when you
here.
plug it into
Well,
That's
all
right.
right, all right.
Yeah, that just
Okay.
answers
Yeah, it can be
my
like a little
question.
All
dot.
right.
Okay.
So I guess the question is, let's take a derivative, right? Let's find. But this is like a cubic, right? And the cool thing about this cubic is, just from our pre-calc knowledge, that's a cubic that has a 0 at 0 and a 0 at 4. There's our other 0. But it's also got a cubic. See, the thing is, you need calculus to help you find the exact max or min, but you already know that this is a cubic that hits at 0 and 4 and 1.5, but it's a positive cubic, so it's doing something like this, right? So I think we got to find that. I don't know where it is yet. We're going to find out.
Just goes right like that.
All right. So favorite way to take a derivative of a cubic that's factored?
Product.
Triple product rule. Or
Distribute.
Yeah,
distribute.
It's better that way.
Or
Let's do
down.
that one.
Yeah, just.
Probably not doubt.
No, I will not doubt.
Bill, cut to me so I can
24 minus, what have I got here? 16 minus 6x's plus 4x squareds. It looks like I've got 4x cubed minus 22x squareds plus 24x. Hey, look, there's my volume, right? And I just got to take the derivative. Super, super clean. Uh-oh.
Equals.
Yep.
Take out a 12.
Take out a
4.
4.
Yeah.
Oh, hey, I get to factor. Yes. Oops, that's not right.
Yeah.
There it is. Okay. Uh-oh. Now you did quadratic formula because you love that. Okay.
Just there's two. The C term was positive and the B term was minus, so there's two minuses.
It's gotta both be negative.
The Gucci gang is flying.
6, 1. 3, 2.
3,
3,
2.
2.
3 here.
Yep.
3, 2. Just like guess and check, right? Is that good? Or like keep going until you figure out what it is. Let's make sure. Check the outer inner. -9 minus 2 is -11. All right. So x is 2/3, which I'm guessing was this 0. And x is 3, which is going to be this 0. But this is the one I want. Now you're like, let's sign test this. All right. Well, if you sign test volume, you already know it's going to be 0 to 4. And we're going to have a 0 at 3. And we're going to have a 0 at
1.5.
2/3. Oh no.
Oh no.
0 at 2/3. Hi, I'm filming a question right now, but I'm almost done. Okay, you're on the video. Say hi, Mrs. Mac.
Hi,
Mrs.
Mrs.
Mac.
Hi,
I'm
Mrs.
almost
Mac.
done. Be right there.
It's
Okay, bye. All right, we're almost done. That was cool. So now, oh shoot, 1/3 into here is negative. 1 into here is positive negative.
Negative.
Oh, just like I wanted. Which we're
Yay.
gonna do. And then 3.5, positive. You're like, I didn't like that. I'd rather do a second derivative, which is okay, right? Nothing wrong with that. What's my second derivative?
24x minus 44.
Okay, so now if I stick in my critical point of 2/3, 2/3 of 24, 16
Minus 4.
minus
That'd be
44. That's negative, that's good.
Which is good.
That's
Concave
max.
down, that's max. Hey, I proved it's max. My dimensions, though, are 2/3 by 8 minus 4/3. 24 minus 4/3. 20/3, thank you. 20/3 by 3 minus 4/3. 9 minus 4, 5/3, is that right?
Yes.
5/3? Hey, there's my dimensions to maximize the volume, and my maximum volume is
200
200,
third.
27.
Oh,
227 feet. Feet?
Well, it just asked for the dimensions.
Feet cubed. That's just for fun. Bonus. Okay, thank you. And there's the answer. There you go.
Woohoo!
Yay!
Yeah,
Yeah, Mr. Matt.
Yay for Matt.
Hill Supreme Mr. Matt.
That's kind of
No, no, no.
Oh, you'd be a great leader, actually.
All right.
We can-
Yeah.
Wait, we're cutting.
Yeah, we're cutting.